815, which is like your 816 that's assigned, very similar. So it says a normal population has a mean of 60 and a standard deviation of 12. You select a random sample of 9. Compute the probability the sample mean is greater than 63, or is A, less than 56B, and between those two. Okay, so we got a normal population mean of 60 standard. So we're quite a bit less when we're looking for greater than 63. And we're less than 1 standard deviation away. But we're greater than, so from the mean of 60 to go greater than is 50%, right? So we're going to be something less than 50%, but we're not a standard deviation away, which is 34%, something like that. So somewhere in between there is kind of what we're looking for. Maybe let's take a look and see where we're at. I might be wrong looking at my answer there. So we get a mean of 60. I put all my stuff in, my standard deviation of 12, my n, and my square root of n, because I've got to use this formula where we look at the bottom of page 270. Okay, when we know the standard deviation. Okay, so it's x, or our mean. I'm sorry, x is the number that we're looking for, minus the mean, okay, divided by the standard deviation divided by the square root of n. Okay, so my x is that, and I got to find my z value, right? Okay, so I plug it all in, and I've got z is equal to, and again, you might want to break up the formula a little bit, and that's kind of up to you if you want to, but it's equal to parentheses my x minus my mean, parentheses, divided by my standard deviation, which I know. Okay, I'm going to use another parentheses because that's then divided by the square root of n, and I've already calculated the square root of n, right? And that one we could almost do in our head, the square root of 9. Okay, so I do that, and I end up then with z is equal to 0.75. Again, then I can go into the back of the book, whatever page that's on, and look at that chart. You guys should, just to kind of get used to it. Or I can come here, right, and I can go to 0.75, which is 0.2734. Okay, 0.2734. Well, that means that's how far away I am. Again, if I'm looking at the standard normal distribution, okay, and we do have a normal population, okay. So my z, I'm just kind of looking at that at the bottom there, getting to the 0.75. There you go. Oopsie. Okay. So it's 27.34%, but is that what the question is asking? No, it's asking greater than that. So it really wants to know this area here, and I think I can do that if I click this one, right? Okay, and what I should do, though, I can just take it times point, or minus, subtract it from, 0.5. Okay. But what I would end up with is 22.6, and again, 22.66. Okay, and that would be a percent actually. So when I look it up, I come up with this number, but think of that normal distribution, and that gives me that idea. So I'm 22.66% is a chance that my sample mean is greater than 6.3. Now, less than 5.6. Okay, I do all the same math. Right, I plug that in, put her into my deal. I actually come up with a -1, so I'm 1 full standard deviation away. Basically, is what I'm looking at there. Okay, and that's kind of odd, isn't it? Because the standard deviation's that, and I'm only 4 away, but it's because we got to put in the the standard deviation correction factor, whatever that is, because we're using a sample mean type of a thing here. Okay, so if I look at that again, okay, now I'm gonna 1, boom. Okay, but I want less than that, so again I want this part here, and I think I can do that, and that'll do it. There we go. Okay, so 15.87 is where I should be, right? 0.3413 when I look up the -1, or I look that up in the chart. Okay, 0.3413. Okay, but I've got to subtract that from, again, that 0.5. Okay. Now the other question then that it asks is, what is it between those two, right? That it would be between those two. It's actually then, I mean, this is to the far right, this is to the far left, and so it's somewheres in between those that you could actually then take 1 being our total and subtract both of those would be correct. Okay, or you can add these two inverses. And again, if we kind of take a look at it here, what we're looking at is, let's try this one. Yeah, I don't know if it really lets us do it. Yeah, there we go. So we're looking at this particular area plus 0.75, right? Plus this area. Okay, so we had that 0.34 whatever plus this, and if you add those together you end up with 0.6147. There you have it for 8-15.